Alright guys, so here it says replace the distributed loading with an equivalent resultant force for part A. And then for part B we have specify its location on the beam measured from point O. Okay, let's get started. Here we're giving that W naught is equal to 3.2 kilo Newton meter. Okay, so the first thing we're going to do is we're going to break it up, right? So we can see that we have two triangles here, right? We have one, and we have another one right here. Okay. And we know that in the triangles, the force is going to go from, it's going to go right here. This we'll call it F1, and we'll call this F2. Okay. We know in the triangle the distance between here and to the force is 2/3, and then from this distance from here to here it's 1/3. You just gotta know that. Okay, so let's get started. F1 equals 3.2 times and all that over 2, right? And then here we should get 4.8 kilonewton meter. For F2, we should get 1.5 times 3.2 over 2, which gives us 2.4 kilonewton meter. And we know the resultant force is just these two guys added up, which gives us 7.2 kilonewton. So this is for part A. Now for part B, specify its location on the beam measured from point O. Okay. So O is right here. And we want its location on the beam measured from point O. Perfect. So the moment from O is we get our forces 4.8, which is right here, and the distance from F1 to point O, so this right here, is 2 meters, because we're calculating from the 2/3 of the triangle. So 2 meters plus the force, the second force, which is 2.4, and then we calculate it from how far O is. So it's all this. So it's 3 plus the 1/3 of 1/5, which is 3.5 meter. And that should give us a solid 18. Yep, 18 kilo still not done yet. To calculate the distance, we just found out moment. So we have 18 kilonewton meter is equal to the force, which is right here, we found right here, 7.2 kilonewton times D. So you just divide 18 divided by 7.2, and D should give you 2.5 meters. Final answer for part B, and final answer for part A.